Guys and girls, it's Noah time! Noah time!
Alright, so I want to continue on with set notation part 2. This is a bit more confusing. Yesterday, I only taught you how to do basic set notations with about 5 or 6 elements. Set notation part 2. Okay. Part 2. What do you do? If there are too many elements? There are too many elements. Because yesterday I taught you a simple one. I have 5 car makers. You break them into 2 categories. You can write everything into one Venn diagram. But what if I give you something that has too many elements? For example, the numbers create a set notation. Notice I'm using set notation. I'm not asking for a Venn diagram anymore. Create a set notation for numbers from 1 to 5. That's what we did yesterday. We're not going to do 1 to 5. Too small. 1 to 50. Some of you say, Miss Snow, I can write 50 numbers down. Not from 1 to 50. Too small still. 1 to 500. If I were to do a set notation for all numbers from 1 to 500, it would take too long. You would use too many lines because you would go 1, 2, 3, 4, 4, so on. And here's your second criteria. Okay? You must show subsets that are multiples of 5, that are multiples of 5 and another subset for multiples of 10. For multiples of 10. Okay. Now, I'm going to start and guide you along first because this is the first time most of you done something this complex. See, in this case, 1 to 500 takes too long. I don't want to sit here write down 1, 2, 3, 4, 5. So what we're going to do is I'm going to start with my universal set. We're going to write down U. Everyone has a different letter, different on what they want for universal. I always start with universal with U equals to this lovely weird bracket thing. Okay. And normally we would write down 1, 2, 3, all the way to 500, but I don't have time for that. So we're going to go dot, dot, dot. 498, 499, 500. Okay. So some of you say, hey, Mr. Snow, why can't I use the dot, dot, dot approach? And the problem with this is, I'm going to write this down. This is not good enough. You could, but you're going to lose marks. It's not good enough. Because the reason why is, you're making me playing the guessing game. What goes in there? I could just say 3.5. It doesn't work. So we're going to use math formula. Here's how the math formula works. We're going to write down U again. I'm going to turn all of this into a formula now. So this is where it gets a bit tricky. Equals to, there's that weird bracket again. We're going to write down X. Because X could be any number. And this is where it gets a bit new for most of you. Okay. Sorry, I'm going to use a vertical bar, not a comma. Vertical bar. Okay. What this vertical bar means, after this, you're going to write in a formula. Okay. This is where, most generally, this is your formula. He goes here now. Formula. Okay. So I started off with X, which means I'm going to use X in my equation. That's what it represents. Now, if I want to include all numbers from 1 to 500, we're going to write down x can be any number less than 500, but it has to be greater or equal to, than 1. Okay, look at my formula. I'm saying x can be any number less than 500, but greater than 1. So it includes, so right off the bat, I turn this into a formula. But there's one more tricky thing you gotta be careful about. Now, to prevent people from using decimals, you're gonna write down one more thing. Okay, you're gonna write down x followed by this fancy e. Not all reals. Now I'm going to choose a new one for you, n, which means you're only allowed to use natural numbers. This forbids you from using decimals, because otherwise some people say, Mr. No, what if I go 2.2? Okay, this means x has to be a natural number. Yeah, only whole numbers. No negatives. Okay, let's be a natural number. That's what little xen. Without that, you're gonna make mistakes. So look what I did for my equation. I turned this into a formula. Now, part B of this question. There are two subsets. One subset has a multiple of 5. So I'm going to show you. Start off again. Choose a letter you want for multiples of 5. We'll call this F. Okay, stands for 5. F equals to, give me a number that's a multiple of 5. Leinard, give me a number. Nope, not 1. What number is a multiple of 5? Oh. Multiple of 5 means you can divide it by 5. 10 works. But before 10, there's another one. 5. See, 5, 10, 15. Of course, you can go ... 500. But the problem is, I can't do this. It's not good enough. Because I don't want you to play the guessing game of what goes there. I'm going to turn this into a formula. I'm going to start this off. F equals to, right off the bat, the first thing has to be an x, followed by a formula. This is where I'm going to pause it and let you... eeny, meeny, miny, mo. Let's see, who should I ask ready to roll? Manraj, take a guess. You know? Idris, take a guess. I'll give you... It's 5... Nope, not less than or equal to. It's just 5 times something. 5x. Because would you agree that if x equals to 1, I get 5. If x equals to 2, I get 10. If x equals to 3, I get 15. But we got to do one more thing. What's the last thing that goes here? X. Nope. One more thing. Xen. Which means I cannot use decimals. I cannot use negatives. I have to use natural numbers. Guys, gals, look at my formula. This is called how we write down the proper subset. But there's one more. I say there's another subset for multiples of 10. How would you write that? I'm going to pause it again. Good evening. What do you have for this one? Yep. 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 X. Line. 10x. Good. Line. And this is going to be xen. Without this xen, people will use decimals. People will use negative numbers and all this stuff. Guys, gals, there are my two. This is how I created my set notation. Okay. I have the universal one, which is here. And I have the t. T means stands for multiples of 10. Now, I'm going to write this using brackets. So tell me which is true. Is this true? You're going to write down true or false. Okay. My first one. U F. Hard jazz, I haven't asked you today. Is U is a subset of F? That's false. Because U is a universal. Universal always goes at the end. Okay? Chris, F U. No, I don't mean F U. F bar U. True. That's a true statement. Okay? It means F is a subset of U. Not F, you know what I mean. Oh, yeah. Okay. This is because F is a subset of U. A bit more challenging. F T is F a subset of T. T is multiple of 10. So they're saying, is something a multiple of 5? A multiple of 10. That's what they're saying. The answer is false. Okay, so here's the reason why. This is saying, is something a multiple of 5, a multiple of 10? So would you agree 5 is a multiple of 5? But is this a multiple of 10? No. But if I ask you T, F, is something a multiple of 10, a multiple of 5? Yes. So this is now true.
So they're not disjoint.
So these are not disjoints. Very good. Yep. Good. So now, next one I was about to ask you, T and F are disjoints. Okay. Disjoints. Leonard, T and F are disjoints. True or false?
False.
This is false. The reason why is, when I draw my Venn diagram, look how I'm going to draw my Venn diagram. So here's my U. There's my U. I'm going to draw my little circle F. It stands for multiples of 5. If something's a multiple of 5, my T is in here. 10 is a subset of F, which is a subset of U. Guys, this is the level I want you to be focusing on. And this is where I want you to be. Try this now. Okay? Good luck. I'm going to give you a question, and then after this we're going to take a break. I'm going to give you some questions to practice, and then I'm going to take over the class again. Next one. Numbers are 1 to 240. That's my numbers from 1 to 240. Okay. I want create a set notation. You're going to create a set notation with subsets. Okay. Now, if you weren't here yesterday, I know you're a bit confused. Come after school and I'll try to explain it as best as I can. Subsets for multiples of 4 and 12. So you have two subsets. One subset is a multiple of 4. One subset is a multiple of 12. Guys, gals, go. Okay, I'm going to pause it. First thing, I'm going to create my universal set. Again, I'm not going to write down all the numbers from 1 to 240. It's too long. Who haven't I picked on today yet? Hema, what's your U going to be? You have to do U. Inder, what's your U going to be?
X.
Yep.
The line thing.
Yep.
And then 1.
Yep.
Greater than or less than X.
Yep.
And then greater than or equal to 240.
Yep.
And the line thing.
Yep.
XEN.
Or XEN. Good. See, the purpose of doing this. Oops, sorry. Let's do my thing properly. Ugh.
Put a comma there or not?
You should either way is fine. See, the purpose of doing this right here. Notice I save a lot of room. Okay, I don't use the dot dot dot. I repeat, the dot dot method is not good enough because I can put in any number when you go dot dot dot. But for this, I'm restricted to only whole or natural numbers from 1 to 240. Okay. Now I know I have subsets to work with. One subset is a multiple of 4. Mario, I haven't asked you yet. Mario, what is it going to be for multiples of 4? How do you write that subset? F. First, F. Yep. F of X. Yep. Yep. 4. Yep. 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 Good. See, this means choose any value for X you like. Any value. That is natural number. When I put in here, I get 4, 8, and so on, so on, so on. Okay? And Jason, let's end this off with 12. We'll use T for 12. What is it going to be, Jason? X, yep. Yep. Good. XEN, good. So guys and gals, I'm going to pause it right here. And this will wrap up my set notation part 2, how to work with complex formulas. I'm going to give you about 20 minutes just to practice this stuff. I'll go over this, and I will show you how to do more complex Venn diagrams after. So I'm going to pause it.